Hello again. Today we will start with chapter 2. In this chapter we will understand concepts related to energy and first law of thermodynamics. We will understand energy including internal energy, kinetic and potential energy, work, power, heat transfer and heat transfer modes. We will apply also closed system energy balances and correctly apply the sign conventions for work and heat transfer. We will conduct energy analysis for power cycles and refrigeration cycles, heat pump cycles, and calculate the thermal efficiency and the coefficient of performance. So first, we will try to develop or to review the mechanical concept of energy. So from mechanical point of view, first we have two types of energy mainly, which are the kinetic energy and the potential energy. So we will start with the kinetic energy concept. Suppose we have a body of mass m where there is some applied force F to the right and the weight mg downward, and the body initially was at a position x1 at some time instant t1 F, and after some time to t2 the body is now at another position x2 and at instant t2. If we apply Newton's second law on the body, summation of forces equal m into acceleration, and we project this equation in the positive direction to the right, we will obtain summation of the forces, which is mainly just F equal m into acceleration. So we will write the acceleration as the derivative of velocity with respect to time. If we apply the chain rule and write the derivative dv over dx into dx over d time, so we will obtain this derivative of position with respect to time is v. So mv dv over dx. So now, if the following equation will be f dx is equal to mv dv, and if we integrate from x1 to x2 and the velocity here from v1 to v2, we will obtain the first term is regarded as the work from 1 to 2. Integral of f dx is the work, and in the second term it will be equal half m v2 square minus v1 square. So this is the concept of, or the theorem of kinetic energy. So the variation of kinetic energy in the system of kinetic energy is equal to the sum of work of forces acting on the body, to sum of work of forces acting on the. So any work applied on the body, or any force applied on this body, and we have a displacement, the work will be stored in the body as kinetic energy. So the work will be transferred to the system as kinetic energy. The other form of energy is the potential energy. Potential energy. If we have the case of free fall of a body, so a body initially, let's take a reference here, z is equal to 0, and the body is initially at some elevation z1, okay, and after some instant in time the body will be at another elevation z2. So at the first instant, initially, the body has a kinetic energy of 0. So no initial velocity is given to the body, and it has the highest potential energy, which is mgz1. And at the final instant, the kinetic energy of the body is half mv2 square, and the potential energy is mgz2. So the mechanical energy of a body is mainly the sum of kinetic energy plus potential energy. So we can say that the mechanical energy at the first instant is half mv1 square plus mg z1, and the mechanical energy at instant 2 will be half mv2 square plus mg z2. We can say that from the principle of conservation of mechanical energy, that the mechanical energy at 1 is equal to the mechanical energy at 2. So half mv1 square plus mg z1 is equal to half mv2 square plus mg z2. So here, as the body accelerating, so here the kinetic energy is higher than 1, but the potential energy has decreased. So the potential energy at 1 is higher than the potential energy at 2. So here what's happening is that the potential energy is decreasing and is being transferred to kinetic energy. So the energy is conserved, but it is converted from one form to another. So energy can be converted from one form to another. The units for energy, in The SI system, it's in joule and has the symbol G. So 1 J is equal to 1 Newton meter. It's a force into a distance. And in English units, it has a unit of BTU, which is a British thermal unit, abbreviation of a British thermal unit, which that 1 BTU is equal to 778 feet pound force. Always you will have some length into some force.